Hello, and welcome to Jeff Does Math. Today, for math, we are going to do some SAT practice, and more specifically, we'll do some unit practice. So, to start us off, let's pick our favorite pen, and let's make it a little bit bigger, big like my treats. Make it brown like my treats, too. There. See, look, just like my treat. Ooh, look at the treat. Or like a little cookie bone. Those are my favorite. Okay, I gotta focus. Okay, I'll get my pen back. Okay, I gotta get the treat color and the treat size. Okay, so let's start off with the first problem. Osmium is the densest naturally occurring element with a density of 22.59 grams per cubic centimeter. Okay, what is the density of osmium expressed in pounds per cubic inch, rounded to the nearest tenth? Okay, so we want to get this into some pounds per inches cubed. Okay, and see down here they gave us what we need to transfer it to that. Okay, so let's take this one step at a time. So we want the grams to become pounds. Okay, wow, we have 22.59, and instead of writing grams here like we already did, notice 1 gram is equal to 0.0022 pounds. So instead of writing this gram, let's just replace that with this, 0.0022 lb. Okay, and then we can start working on the other part. So instead of centimeters cubed, we're going to want to have inches cubed. And 1 centimeter cubed is equal to 0.061 inches cubed. So instead of centimeters cubed, let's write down this 0.061 inches cubed. Okay, and now this is just like how you would normally multiply a fraction. So I'll use this calculator. Wait, does it let you have a calculator? Okay, apparently I thought when you press that you get a calculator. Maybe I've just been eating too many treats and I'm just a little too fat. All my brain got covered with fat, so I'm a little slow today. I'm sorry. Okay, so in our calculator, we'll enter 22.59 and then times, and then we'll do open parentheses 0.0022 divided by 0.061 close parentheses. Enter. And when we do this, we get 0.8147. Okay? And it wants us to round to the nearest tenth. The nearest tenth is 0.8. So let's enter this in. Boop, boop. See, and we got it right. So all you have to do is plug in what that unit is equal to, and then you just put the unit right there. So instead of 1 gram, it's 0.0022 pounds. Instead of a centimeter cubed, it's 0.061 inches cubed. So we're almost using these just like normal variables. You're just plugging it in. Okay, let's do question 2. So let's erase all this. Bah, bah, bah. This is what happens to my food bowl every day. Everything inside it just disappears. I don't know why. I don't like I don't even think I ate it. It's just gone. All my food's just gone. Okay. The vibration in a plucked guitar string travels at a speed of 410 meters per second. Okay. How far in centimeters will the vibration travel in 0.4 milliseconds to the nearest tenth of a centimeter? Okay. And then down here it says there are 100 centimeters in 1 meter and 1000 milliseconds in 1 second. So let's do the math. So first we want it in centimeters. So let's convert this to centimeters. And then we can also convert it to milliseconds at the same time. So 410 and then down here it says there's 100 centimeters in 1 meter. So let's write 100 centimeters. And we want it in milliseconds too. So let's get the milliseconds. 1000 milliseconds in 1 second. So 1000 milliseconds. Okay, so let's convert this. This won't be the answer to the problem because it wants to know how far it'll go when the vibration travels in 0.4 milliseconds. So this is just finding out what this, right now we're just converting meters per second into centimeters per millisecond. This is just to set up what we need to do. So let's do this math. So in my calculator, I'll enter 410 times open parentheses 100 divided by 1000 close parentheses. And here we get 41 centimeters per millisecond. Okay. And now we want to know how far in centimeters will the vibration travel in 0.4 milliseconds. Well, if we look here, our milliseconds is in the denominator, and we want centimeters. So, to get rid of the milliseconds, we need to multiply something with milliseconds. And right here we have what they gave us this, 0.4 milliseconds. So, we can multiply this by 0.4 milliseconds. And since this millisecond is in the numerator and this one's in the denominator, they'll cancel out and we're left with centimeters, which is what we want. See, how far in centimeters? So we'll have exactly what we want. And 41 times 0.4 is equal to 16.44, there we go, centimeters, just like I said earlier, because the milliseconds cancel each other out. And it's asking for the answer to the nearest tenth of a centimeter. That's that 0.4. So we have everything we need. So let's enter that in. And look at that, correct. So for this problem, I let Clumsy try to solve it. And as you can see, Clumsy thought it was 5, but the correct answer is 22. So let's see how we can fix Clumsy's answer and get to 22. So let's pick our favorite marker again, the big old treat marker, that's what I'm calling it. Okay, so they even try to help us. So let's see what Clumsy did wrong. So a baker uses 3 cups of flour to bake 2 loaves of bread. So every 2 loaves cost 3 cups to make. You need 3 cups for every 2 loaves. Okay. But we don't have cups, we have pounds. So let's see. Excuse me, my lunch is trying to come back up. Okay. Let's see what we have to do to make these pounds. So, we want to get rid of the cups. But how many cups are in a pound? Well, luckily it says right here, 1 pound of flour is equivalent to 3 1/3 cups. So we multiply, we want the cups away, so we want cups up here, because the cups want to cancel. So we have 3 1/3 cups for every pound. So 3 1/3 cups per pound. So let's take a step back and look at what we have. So we have 2 loaves per 3 cups. We get 2 loaves every time we use 3 cups. And we also have 3 1/3 cups per 1 pound. So we're just using both of these here, 2 loaves per 3 cups and 3 1/3 cups per pound. And because of the way we wrote this, these cups are in the denominator, these cups are in the numerator. The cups cancel. So now we have loaves per pound. But this isn't the question. We're not trying to figure out how many loaves we have per pound. We're trying to find out how many loaves we can have when we use 10 pounds. So now we want the pounds to cancel. So that means we need to multiply something with pounds in the numerator. Well, what do we have? How many loaves of bread can the baker make with a 10-pound bag of flour? So we have 10 pounds. And as you can see, just like we said, we need something with pounds in the numerator. Well, 10 is in the numerator, and it's 10 pounds. So 10 pounds. And this cancels that. And let's see what unit we're left with. Well, we don't have cups anymore, and we don't have pounds anymore, and we have loaves. And what's the answer in? Well, how many loaves of bread can the baker make? So we have exactly what we want here. So now we just have to plug this in to solve. So 2 over 3 times anything in the 1 in the denominator, the 1, that's just the same thing as writing what it already is. So that's 3 1/3 times 10, and that's going to give us our loaves. So let's do this math. So in your calculator, you're going to want to write open parentheses 2 divided by 3, close. Oopsies, that was a little messy. Sorry, sometimes I eat a little messy too. It's pretty messy. You don't want to be there. You don't want to see that. Okay. Times, open parentheses. Well, 3 is equal to 9/3, and then plus another third is 10/3. So open parentheses 10 divided by 3, close those, times 10. And so once we enter this in our calculator, 2 divided by 3, close parentheses, times, open parentheses, 10 divided by 3, close parentheses, times 10 is equal to 22.2222222. Okay, as you can see, it's just 0.222222 forever. And it wants us to round to the nearest whole number. Well, 22 is the nearest whole number. And as you can see, there's the answer.